System Design and Management program provides a systems thinking perspective that integrates management, technology, and social sciences to address rapidly accelerating complexity and change in today's global markets. Graduates earn a Master of Science degree in Engineering and Management. The SDM program also offers a one-year certificate in Systems and Product Development. We're pleased to have Christine Miyachi present today on challenging common software design principles. Ms. Miyachi has almost 30 years of experience working for startups and large corporations and currently serves as a systems engineer and architect at Xerox Corporation. She works on Xerox's Extensible Interface Platform, a software platform that enables developers to use standard web-based tools to create server-based applications that can be configured for the multifunction peripherals touchscreen user interface. Ms. Miyachi holds several patents. She graduated from the University of Rochester with a BS in Electrical Engineering. She also holds 2 MIT degrees, a Master of Science in Technology and Policy, Electrical Engineering, and as an SDM alumni, a Master of Science in Engineering and Management. She's currently the chair of the IEEE Cloud Computing Steering Committee. Ms. Miyachi will explore today what lessons software designers can learn from other areas of design. This webinar will explore such questions as, must software form always follow function? Can software be designed for beauty first? What happens when software designers break the single responsibility principle? And what are the pros and cons of abandoning common principles in crafting software? Ms. Miyachi will present for approximately 40 to 45 minutes, and then we'll open up the webinar for questions. Please use the chat feature on the webinar to ask questions, and we'll respond to as many as possible. Thank you for joining us, and please join me in welcoming Christine Miyachi for her talk today.
Welcome, everybody. So today we're going to talk about several common software design principles. Some of them are not just for software, they're for engineering design and architecture design in general. And I'll go through some of the history, which some is from a while ago, some is pretty recent, as even in the 2000s that some of these principles got started. But they do have roots that go back at least to the 70s and sometimes even 100 years. We'll talk about iterative development because that's really common today in software development, and the famous phrase, form follows function. And then from there, we'll talk about the solid principles, which have become very popular in software design. And the SOLID is an acronym that stands for the single responsibility principle, the open-closed principle, the Liskov substitution principle, interface segregation, and dependency inversion. If you don't know what those are, that's okay, because I'll define them and we'll go through some examples. And then we'll end with software craftsmanship. So if we talk about some of the history here, a lot of the principles actually came from the development of the Agile Manifesto. And to even, and the Agile Manifesto came about in 2001. A group of very well-known software professionals got together and they came up with some principles, and here they are on the screen.
Perfect.
Hello? Individuals and interactions, processes and tools, working software over comprehensive documentation, and customer collaboration over contract negotiation, and responding to change over following a plan. And so a lot of these principles actually developing software iteratively was a result of working on these principles. And iterative development actually has some roots in the 70s. It was started, a man named E.A. Edmonds wrote a paper that introduced it. And Scrum, which is an Agile process, before Agile was invented, is also iterative, and that was around before this. But the Agile Manifesto actually came about, I think, in reaction to the capability maturity model. So the capability maturity model was a very heavyweight waterfall style software process. If you don't know what waterfall is, it's not iterative, or at least the way it was defined in the old days. It's not iterative. You did all your design up front, then you did development, then you did test, then you delivered the product. And if it wasn't what the customer wanted and you did all that development, you had a big problem. But the CMM was developed, and it was mostly used by government contractors so they could certify subcontractors in their software development processes. Were they actually doing good software? How could they tell? Well, the CMM was able to measure companies in a certain way. And I worked for a company that was heavily invested in the CMM. And we had a huge team that did audits on everybody. And we had a lot of documentation. So we spent more time addressing the CMM than we did delivering products. And then when one of the recessions hit, one of the many that we've had in the past, a recession hit, and that group immediately went away. And that just goes to show, well, in that case, was it really worth it? I don't know. I do think there were some useful things in the capability maturity model. It's still around. I don't know anyone that uses it. Agile was a direct reaction to CMM. So notice CMM was all about heavy documentation, making contracts, following a plan, and having big processes. And this group of software professionals really pushed against that and said, I'd rather collaborate with the customer, I'd rather be very responsive to change rather than gold plating requirements, and I want to deliver working software over time rather than documenting it, because the documentation doesn't do anything if you don't have the software. So moving on, this page, you've probably seen this. This is an old cartoon. It's not really, it doesn't really show iterative development, but I'll give you some examples using it. So an iteration is defined as a process of repeating a set of operations until a specific result is achieved. And when we develop software, we usually can develop something quickly for stakeholders to review. And from that feedback, we can revise the design. However, stakeholders often don't know what they want. So iterating, when you iterate, you actually help stakeholders figure that out. So this funny picture shows a lot of the stakeholders involved and how it can go oh so wrong. Both CMM and Agile were created to address software's high failure rates. So both of them were trying to say, okay, how can we make the development process better so that we're more successful? Agile, iterating through software became a direct result of the Agile processes, and it can help this picture, I will say from experience. So the customer probably did explain that first picture. The first picture says how the customer explained it. And the first iteration might deliver that first picture. And then the customer would say, oh, but it doesn't swing. Okay, so we'll make it swing. So we delivered the third picture. Oh, but wait a minute, I need it to go in a circle too. So the fourth picture wouldn't happen because it says how the programmer wrote it, because the programmer was writing it all along. It wasn't, the programmer, when you're iterating, you don't just deliver one big package, you do it in little increments. And then here the descriptions don't matter so much in how the consultant described it and how the project was documented, because we're using Agile development, and we put emphasis on working software over comprehensive documentation, which is where the value is. It's not so much in the documentation, although it is, the documentation is valuable. I'll talk about that a little later. There wasn't a separate installation. It was being delivered all the time, so there isn't this one big fat installation at the end. There's been little installations all the time, so you don't get something like this second to last, this second row, second picture. And then how the software gets supported, well, in an Agile process, all the stakeholders are involved, including the support staff. This is how it should be. It doesn't often happen in real life that way, but that's how it should be, so you wouldn't get this weird issue of how it was supported. And iterations would hopefully, this picture would change quite a bit. It may start out like this. You may get these two, and then slowly over time you'd get this ending picture. And you might even get hooks on the rope so that the support staff could actually replace things easier. So that's how iterations can work and work well. But iterating also may fail. So with each iteration, the design cycle should narrow the possibilities of change so that the project can move forward. For iterating to work with software or, really any product design, all the stakeholders must have a clear picture of the final product. But in practice, that doesn't work. It usually isn't the case. Usually we don't have a very clear picture in the beginning. The customer has one vision, several iterations are completed, and then a new vision emerges. And this, in Agile process, is considered a positive, as iterating is a discovery process for all involved. But most stakeholders, especially the stakeholders paying the money, need a finish criteria. And usually there's a date involved as well as how much money to spend. So if you're going to take a customer on a journey to figure out what they want, it should be clear that what the expenses are for them to wander all over the place. And years ago, when I was working for a group that was introducing, they were trying to bring Agile process into the company, the managers couldn't get it because they said, well, how do we know when we're done? And, we need to be able to predict in the beginning how long it's going to take. And they were having a lot of trouble with that. In reality, no one ever really knows how long it's going to take, but you still can predict with Agile process, especially with Scrum. So I've been involved in several projects that did not converge. In one particular project, it was an internal project. I was supposed to document an architecture so that other engineers could work with it, the whole system. I was supposed to document the architecture on a high level and break it down and so forth. And I couldn't get the stakeholders to agree with what our system was. It was amazing. I finally was getting somewhere. I was iterating over it several times. I was honing into it. And there was one stakeholder, he hadn't been that involved, and all of a sudden he got really involved, and he had a whole different viewpoint. His idea was actually very interesting. It was a whole different view on the system versus the view I was taking, but I was running out of time. I didn't know what to do. So I couldn't get the stakeholders to agree. So I drew up a financial statement for my boss, and I said, this is what the time I've spent. This is what I would have to spend, and I estimated what my hours were costing the company, and I said, is this worth it to you? And it wasn't, and so we stayed with what we had, and we'll get back to that. That often happens. You run out of time, and you end up staying with what you have. I did recommend that that's what we do as well. But there was another twist on this as well. What I noticed is that the president of the company where I was working at the time did an architecture. And he wrote something up. It wasn't really that great, I hate to say it. It wasn't terribly wrong, but it wasn't right, and it wasn't very descriptive. And but he did try, you know, give him credit. He asked people for feedback. No one would tell him it was wrong. Like instead, in my case, everybody was telling me it was wrong and giving me loads of feedback, and I was driving myself crazy and running around in circles. They wouldn't tell him. And this was before I started. It was like I almost started with his, and I was working from it. But everyone said it was good and correct, and they just couldn't give him the feedback he needed. So that's kind of another twist on this. You've got to have a group that's honest with each other, stakeholders that are honest with each other. So, and he wasn't able to get that. It wasn't used by anyone except him. He would use it in his own presentations, but no one else used it. So getting back, iterations often don't converge in real projects because we run out of time. And I want to show you some examples of iterations and non-convergence. So last fall, I went to Copenhagen and I visited. Copenhagen is a center of furniture design, modern furniture design. It was very popular in this country in the 60s and 70s. And this is a picture of iterations of furniture of a particular very famous furniture designer in a museum I went to, and he iterated over his various chairs that he was working on. And let's see, I was fascinated to see this. So this was in the 50s, and people were iterating. So you can see iteration does go back quite a ways. When I saw these chairs, though, I thought they all looked beautiful. They didn't seem like they were incomplete. Part of this is the nature of furniture design versus software. I guess he couldn't have built just the legs of the chair and used that. He really had to build a whole chair to get the sense of it. But in this case, it seems like I couldn't figure out what his goal was. Then again, he wasn't there to talk to. I did get some idea of what the goals were. But anyway, looking at the first row, he started with something very traditional here. This first one on the left in the forefront, it's very almost colonial-like. And then he made it smaller and simpler. And then he made some radical changes. So here he used leather for the seat. And then he took away the whole back. And the last chair looks like it's less supportive, but it's simple and beautiful in this first row. In the second row, it looks like something was taken out in each iteration. You can't really see the very last chair, but there's less of a back on it. It's lower. And these chairs in the back were all made to fit underneath a table. So you can see that he got lower and lower and lower each time. He fiddled with the color a little bit. And he ended up, what is interesting about this is he ended up something simplest at the end. It was the simplest design that he ended up with. And that's often true with any system you're working on, is that the simplest one is often the most beautiful, or it's the best thing. It's not necessarily, it won't meet all its design goals perfectly because there are trade-offs to be made. And sometimes meeting all its design goals won't be the simplest design. But in a lot of ways, sometimes the simplest is the most beautiful. And so moving on from there, what do you do with iterations? So what to do? Iterating is still a great way to break down a large project into smaller chunks. We use this all the time at where I work. We break things down into small tasks. That's how we plan them. That's how we decide what we're going to do first and second and so forth. And we break things down into small chunks. And we use sprints, which are iterative. We call them sprints in Scrum, and they're 2-week iterations. And we break a task down so that we can finish it in 2 weeks. And if we can't finish it in 2 weeks, we break it down even smaller. And like I said before, a design that meets all its goals perfectly will not lead to the simplest design, typically. Can't say, that's never, nothing is ever always true, but sometimes meeting the top few most important goals leads to the simplest design. That's why it's really important to prioritize what your goals are. And the simplest software is often the most beautiful software. So what we do usually, because we run out of time, is we stop before we can make it too perfect. And where I work, in my work, we always stop. Usually we have schedule pressure, so we have to stop before we can make it too perfect. But if moving on to the next principle, we talk about the most perfect form or the simplest form, brings us to form follows function. And this is a very famous saying. For those of you who attended the SDM program, you'll probably remember, I bet every class, every cohort has talked about this slogan, form follows function. It's gone back. It was originally attributed to a monk 100 years ago or more, over 100 years ago. But it really became popular in a book by Peter Blake. He wrote a book called Form Follows Fiasco. And he was railing against, this book was from the 70s, and he was railing against modern design, modern building design. And he felt that modern building design was all form and no function. And so he thought his book is all about that, like where is the function in these modern buildings? And so if the function is met when I think of form follows function, I always thought it meant what Peter Blake said is that function should be the utmost important in any design. And then, but it also has this second interpretation that I was alluding to with the iterations, is that if the function is met in the purest, most simplest way, the form follows and it will be beautiful. And really what you want to do is you want to look at the success criteria, and that really determines what the form would be. And so if we look at the chair in the last row, the last chair looks a little bit uncomfortable to me, but the goal was, it doesn't have a solid back, it doesn't have longer armrests, but if the goal was to fit that chair completely underneath the table, then the design goals are different. They conflict with comfort, but there are trade-offs to be made. And if you saw these chairs fitting underneath a table, it looks really clean and uncluttered. So depending on the goals of the design, what form will meet the design criteria. So let me show you these other examples here. So this is a nice example where you have your digital clock, which is pure function, and then you go down the spectrum and you have pure form, which is no numbers and just the hands on a clock. And you go through the different variations of that. There's trade-offs here. And then I always think of a Jeep. A Jeep is pure function in a car. It's made to be rugged and go over rocks and so forth, and it's really not made to look sleek and elegant, although a lot of people really love the look of a Jeep. I can't say I do, but I'm not really a car person. But so it's, as all these things are, the beauty of form is in the eye of the person. It's more opinion in some ways. So moving on. So I'm going to show you a software example. It's rather simple because I know we have different experiences with software, but this is a recent one. So what you're looking at here is I'm taking a class right now, an Android programming class online with at Vanderbilt University with a professor named Douglas Schmidt, and he's prolific. He is an amazing software architect and designer, and he's a really good teacher as well. And anyway, our assignment was to call on our Android phones, write a program that called the weather service, got the weather, and displayed the weather on the phone. So the weather service returned this data, and this data is in JSON format, which is stands for I think it stands for JavaScript notation, object notation. Yeah, JavaScript object notation. And so this is what it looks like. And if you were going to break this down into a class model, there's the weather, and the weather contains something about location, clouds, wind, rain, snow, temperature, and the current conditions. And each of those has things in it, like the minimum temperature, the maximum temperature, weather, the name of the location, what the humidity is, and so forth. So I'm going to switch to show you some code right now. So just to give you an example, initially he didn't give us anything. So I wrote this. I got some of the ideas online, and I wrote this, and this is a class, and it has lots of other classes in it. So it's got location, current, temperature, wind, and it allows you to get and set different pieces of it. So very simple, right? But it's a single class. Then what he did is he gave us something different. Then later, halfway through the assignment, people were having a lot of trouble with it. So he ended up giving us something different. And what he gave us was a weather class, and the weather class called on other classes to get different pieces of different pieces. So he had a very simple class, and then he had all this. He had a wind class, would get the wind, and so you would get the weather, and then you would get the wind, and then you would get the data from the wind. That's how it worked. And so when you look at form follows function, there's a couple of different things here. Both, to me, are good designs. One is self-contained in one file, and for me, I really liked that. I liked having everything in one file, and it was easier for me to see it that way. Depending on what's easier for other people, this is also very clean. Each file is short, and each class is independent. They're somewhat decoupled from each other. The weather calls other things. It will still compile without those other things, but it calls on the other things and the other pieces, the other objects, and then once you have the object, you can get the data. So both of them are good, and they have different forms, and depending on your goals. Also, for me, I have to say, I'm taking this class, I'm working full-time, I have a family, so I just wanted to get the assignment done. I wasn't as concerned with beautiful form. Douglas Schmidt, if you look at his code, he is a master of writing beautiful code, and if you want to look at, a lot of people don't consider code beautiful. I asked, while I was preparing for this webinar, I asked my 84-year-old mother, who does not write software, so that you know, and I said, Mom, do you I showed her some of the furniture pictures, and she really loved, I said, what do you think is beautiful in these furniture pictures? And let me show you. Whoops. Yeah. So she really liked she liked this picture on the way left. This is her style. This is what she loved. And it was very supportive. She's older. She likes the supportive chairs. Then I showed her some code, And I showed her these two examples, and she thought all of it was very ugly. She couldn't read it. And a lot of people, when they look at code, if they're not programmers, their eyes somewhat glaze over with code. But if you work at all, even if you're not necessarily a software engineer, you probably can tell good code from bad. So I recommend Douglas Schmidt because he is an artist in what he's prolific, and he writes. He's got a bunch of books out, and he's amazing. But you can see. Then I also felt that the single file was simpler in my case. I really did feel like it was simpler. So I stayed with my design, and the program worked fine. So it worked just fine with either one. So let me moving on. If we look again, here's a great picture of form versus function. So this picture is from the MIT campus. It's actually from the same location. And I have some history here because in my first MIT degree, I graduated in 1986. I had an office in this building, this white building, which is a pure functional building. I don't think anyone would say this is a beautiful building, and it really wasn't. And it wasn't inside either. It was very functional. It actually was a legendary building. It started out, it was built very quickly during World War II to do research for, it was called the Radiation Laboratory, or the RAD Lab, and it was, they did research in microwave physics, microwave communications, and after the war it stayed there, and it ended up being what they called a magical incubator for many small MIT programs, research, student activities for about a half a century. It ended up lasting that long. And it was demolished in 1998. But it sat there, and you can see it's like fallen apart. Even in this, you can see it's all patched up and everything. It's pure function. And then this is the status center. This is what replaced it. And this building would be probably what our Blake would call, what was the name of his book? I'll go back and look. Hold on. Form Follows Fiasco. He would have hated this building. Peter Blake, because he would say that it's lost a lot of its function. I don't think this building has. It's really a great building to be inside. Yeah, it is a crazy building. Someone just commented. It is. I remember when I first saw it, I was mesmerized. I think it's made, but that's one of its goals. Its goals was to be a statement piece on campus. And it certainly is. I've heard that there's been structural problems with the building. I didn't really look too hard to find that. I've heard that there's been some problems with it, but I still think it's a great building. I know I've been to a couple of receptions on the top floor. It's a great building to be in. It has a gym. It's got some lecture halls. And I think people are really excited to be working in this building and going in and out. It makes a huge statement piece on campus. So again, depending on your goals, you don't want to have, if they could have replaced it with a modern Building 20 that was just all flat and did the job. The MIT architects didn't want to do that. They wanted something that made a statement, and this does. And I think it does have a lot of function. I don't think function was thrown out the door with this building. I think it really does have some function to it. Although I have to say, I don't know. I'd love to be in some of these strange corners. I don't know what is actually going on in some of these corners, if there's actually things in there. So moving on with form, I would say that form varies with function. So here, going back to my Danish furniture, I found a chair that was brilliantly designed to be a clothes hanger. So is this chair a good clothes hanger? Yeah, it's a pretty good clothes hanger. You know, if you had one shirt and a couple of pants and a belt, yeah. It won't function as a full closet, but it can hang a few things. If you're in a small room, yeah. Is it the most comfortable chair in the world? No. But it's supportive and someone can sit on it even when clothes are hanging on it. And it does keep some elegance with its curved lines and rounded edges. And notice that the form does indeed follow the function. This form is just not a chair that you can sit on. It's a chair that you can sit on and hang clothes on. We have some other examples too. I'll bring that up later because I want to make sure I have time for questions at the end. So while I agree that function dictates form, the simplest form is often the most beautiful form, and it will come from meeting a minimalist set of functions. And one of the ways to do that is to prioritize your goals and at least solve the first and the second one, and then decide if you want to go on and meet more of your goals. And so looking at this picture, this goes into our first solid principle, is the single responsibility principle. So this principle was started by a man named Robert Martin, a very brilliant software engineer. I've seen him speak. He's really animated. He's written a ton of great books. Very smart, really still a phenomenal programmer as well. And what this says is that every class or module or thing should have a single responsibility. And only that responsibility should be encapsulated, and the class or module or the chair should do that and only that. And he gave an example of something that violated that. He said a class that compiles and prints a report violates this principle. So in his mind, that you shouldn't have a single module that does both those things. And the reason being is that if you had to change the reporting function, you would touch the thing that prints. And if you have to change the printing function, you would potentially change the reporting function, and you could introduce bugs. And I understand the need for the single responsibility. It does make things easier to understand. Like in some ways, the previous software example I showed you, each class had a single responsibility rather than my big class that had kind of everything in it. Have you ever worked with spaghetti code, that famous term spaghetti code? And we still have this where I work. We make a change in one area of the system and it unexpectedly affects something else. And our systems are it's a legacy system. The code's been around for years. So, you know, and when you the lines of code add up, you can really get something like that. So his example, right, he says there's no reason for these two things to be coupled. So in other words, like he said, the other thing he points out is that if you have to change the reporting function, and because you change the module that has the printing, you've got to retest the printing function. So that's a good reason why you might want to decouple them. Let me see what's, yeah, but there are some issues with this. So needs change over time, and software is repurposed. So the goal may be to have something do two things at once, to save space or memory or other types of overhead. Here's an example of the chair, but then the other example is a seat cushion in a boat, which serves as a flotation device. It's a very compact way to include in a small area to have a flotation device and then also have a seat cushion. Is it the best seat cushion in the world? No. Is it the best flotation device in the world? No. Another example is a smartphone that serves as a flashlight. It's a pretty darn good flashlight if you've ever used your smartphone as a flashlight. So there are a lot of examples that violate the single responsibility principle, and in software, There may be reasons why you want to put things together in one module like I did, for the sake of time, for simplicity of keeping everything in one file. If you're delivering files, we often do that in this other project. We have to deliver files, so we like to minimize the number of files we deliver because it makes it less confusing. The next principle, this one, I'm just going to go over this very briefly. The open-close principle is that classes and modules should be closed for modification, but open for extension. And the reason why this is important is, I'll give you an example. This picture shows it, but I develop web services and web service interfaces in my current job. And once we release an interface, clients start to use that interface, and they develop applications and products based on that interface. So if we change that interface on them, their product breaks. And so basically we can never change that. And we have to be what's called both forward and backward compatible. So we have to be able to, when we release a new interface, we have to work with old clients and new clients. And new clients have to work with our older interfaces, and new clients obviously can work with the new interfaces. If they work with if they're a new client and they work with an old interface, they can't use new functionality, but they should still work with the old functionality. So that's what forward and backward compatibility. It is crazy making. It's really hard to make a change. In 10 years, I think we've only changed an interface where it wasn't compatible one time. And we had to do what's called a major revision. And we did that, and the client, we kept the old version of the interface still in the system. So if someone had a client, they could still work with the old version, but if they wanted to work with the new one, they had to change their code. But we've only done that once. So I don't have a problem with this. I will say it's very, very expensive to support this. And that's how a lot of these principles are. There's trade-offs into supporting them, and we'll get back to that in a moment. The next principle is the L in the solid. This is Liskov substitution. It was presented by Professor Barbara Liskov of MIT, and she said that in a paper in the mid-'80s, she said if S is a subtype of T, subtype, and then the objects of T can be replaced with the objects of S. They can be substituted in without altering anything. And this is also called behavioral subtyping. And if I'll give you some examples where this actually can break. Hold on. So, for instance, if you say a square is a rectangle, this is what you'll see. This is a classic example of breaking LSP. A square isn't a rectangle because if you change one of the rectangle's sides, it doesn't change if you change its width, it doesn't automatically change its length. In the square, the behavior is different. If you change the length of one of the sides, all the sides have to equal the same. So you can't substitute a square is not a rectangle. So that's an example. And I won't go through this second example in Windows for time, but let me see what I say. Yeah, it's not. Instead of saying that instances of a parent type should be replaceable by instances of a subtype, you'd want to really say that the subtype can't change the behavior of the parent type. So there are ways to work around this. There's some interesting examples online so that you could make a square to be a rectangle and deal with it. but in general, this is actually I'll give you an example that we do at Xerox. We have a multifunction device, and our device is scan, print, fax, and copy. And we have a unit of work called a job, and that job is a job, and it gets passed around whether it's for printing, scanning, faxing, or making a copy. And the system doesn't care. The system will treat all of them the same, and that's a good example of LSP in action and working. But you can it doesn't always work, and it's not always bad that it doesn't work. And all these principles cost money to support. And I'm going to go back to that job example in a moment. Okay, this one is related to the job. So Robert Martin, by the way, he was one of this one is also from Robert Martin. And Robert Martin was one of the founders of the Agile Manifesto. And he is very influential in the industry, and he came up with this principle when he was working at Xerox. So what this one says is no client should be forced to depend on the methods it does not use. And he said this came to him at Xerox because when he was consulting, he saw that they had a job class, and he said that they had a job class that was used for every single task in the system. That's true. And he said a stapling job shouldn't know anything about a print job. And he said that introduced a lot of bugs. And I will tell you right now, there has never been a stable job at Xerox. So I know, because I know the years that he was a consultant at Xerox. I didn't work with him then, but we never had a stable job at Xerox. Stapling is an attribute on a job. So whatever kind of job you have different types of attributes, how you're going to scan the job, what resolutions, whether you staple it, whether you fold it, whether you collate it. These are all attributes. There isn't a staple job. And so I really thought that, I don't know where he got this principle. It's not a bad principle, but I don't see the interface segregation principle in practice very often. For instance, if you work with Microsoft Windows or Java and you work with the UI classes for the various attributes for creating UIs, they have these massive classes for Windows and for the panels and so forth, and they don't break things up. And they are complex, but you use what you need. You look through the documentation and you use what you need. And so I don't really see this one in practice that often. There's a cost to breaking things up. So this example I showed you earlier with the weather, there's a cost of breaking things up. Sometimes there's a gain depending on what you want. Let's see. So I said this already. A job doesn't violate ISP. There is no staple job. Jobs can be moved through the system without the system knowing what they do. And based on the job properties, things will occur while processing. So I would love to talk to him more and find out where this came from, because I don't think it's right. And I don't think Xerox ever had a staple job. The final one, we're almost done, is dependency inversion. And what this says, I want to just go through this one quickly because this says that high-level modules should not depend on low-level modules. Both should depend on abstractions. And abstractions should not depend on details. Details should depend on abstractions. So this one, I understand what they're doing. So let's say you wanted to call a function in another class. And so this is very straightforward. X needs to call a method on Y. Just do it, right? Well, what this says is, no, don't do that. Call the interface and have Y depend on the interface so that they're decoupled. So an interface is something that you can create in an object-oriented environment. Object-oriented languages support it, and it's not a full object, and it allows you to decouple objects. That's okay, but you can see this is a more complex structure than this. The right is a more complex structure than what's on the left. And so there is a lot of benefit to this, to decouple things, and just depending on what your needs are. Imagine if you had to call just a string creation and you had to do, something very simple, and for everything you did, you had to use the dependency inversion principle. I don't think it would work, and all software would be very complex. But there are other cases when it's really needed, when the lower level code is changing a lot and you want to just depend on the interface versus coupling with that code that's actually changing a lot. So when you create a dependency, there's a risk, and handling that risk has some costs, and sometimes it has to do with the life of your software. If you're writing a homework assignment that's not being shipped, I think it's, and you have a short deadline, maybe not use that principle. But if you have something, like we have areas in our code, I've done some analysis, and I've looked at what areas of our code changes a lot, and it's worth actually doing something like this. I am going to skip over software craftsmanship. I will say that this is a movement. Software craftsmanship is a movement about being a craftsman and creating your software. So I gave the example, I'm just writing a homework assignment. But if I was the utmost craftsman in software, I would write it in the best possible way because I'm a craftsman. And I like a lot of what this is about. The problem I have with it is I work with so many different types of people in different levels. This is the stages of the software craftsman, and they have definitions. I won't have time to go in them, but a lot of people I work with that are so many different levels, and you're not always working with very high levels of productivity. So I would say that it's a great notion, but a lot of people never get to these higher levels. So in summary, most of the principles were built upon previous principles that have been around a long time, and I think there's truth to all of them and some solid usefulness to all of them. But depending on the context, principles should be violated. Adhering to these principles is not free, it's expensive, and most teams have people that don't have the skills to follow all these principles. Following these principles can introduce bugs too, because they can make your code more complex. So I think there's no free lunches. All abstractions have a cost. That's one of my takeaways from this. And thank you.
If you can send any questions that you might have using the chat feature on the WebEx system, Chris can answer them for you now.
So I have a couple questions that came in. The first one says, do you think the next 5 years some principles are going to change? I do, and I'll tell you where I think the change is going to be. So Agile development is all the rage, and what's happened is people have gotten away from long-term thinking, and there's been a big cost to that. So some more long-term thinking is going to come back into the Agile process, and it's not going to be just trying to get some code working without any documentation. Documentation is worth a lot more than what the Agile manifesto claims it to be, and I think that you're going to see some big changes in that direction. The next question is, do you practice TDD, test-driven development. Yes. So TDD is an Agile method. It was around before the Agile Manifesto, and test-driven development is creating your tests before you create your software. It's very, very powerful. I believe a lot in it. If you've ever done some of the more modern programming languages like Ruby on Rails, you write your tests and you develop your code, and the tests immediately get run, and all of them don't, like your first iteration, all of them don't work. But it is a very powerful feedback tool for development, and we do practice it. We practice it in a more manual form. We write all the requirements, and then we write the tests for those requirements before we even write code. So yes, that is part of our process. Another question is, what is the relationship between tight cohesion and loose coupling with your methods? Well, a lot of these principles are really to loosely couple classes and modules and pieces of the system, because when you tightly couple things, if you change something in one area, it's going to affect something in the other. Cohesion is the ability to fit together in a clean way. And that's all of those principles are trying to get tight cohesion and loose coupling. That's kind of the goal. The next question is, the interactive process in Agile Scrum seem more like a discovery process of what the final process should be. It seems inefficient to discover. You know, that is true in some respects. It's like you can't be lazy. It almost it's like there's a book that we read back when I was in SDM. It was called The Fuzzy Front End. I don't know if current SDMers read it, but it was in one of the classes we read it. It was called The Fuzzy Front End, and it was about how in the beginning of the project everything's very fuzzy, and it's a huge waste of time that you need to figure out what you want and how you want it quickly, so that you don't have that long, drawn-out, fuzzy front end of your project. And it is inefficient, and it's costly to have that as a discovery process. That's why you need to know what you want. It's going to save you money. Let's see. Chris, do you have examples of formal principles that in practice are not practical and are best not to be followed? You know, I don't have anything that's all bad. Like, I don't have a particular principle that I would never, ever, ever use. Like, all of those have some value to them, but I wouldn't use all of them blindly. That's really your takeaway here. I wouldn't use any of them blindly. Last question, I think, Joan. This will be the last one I take. It seems to me that the high overhead, more formal principles are more important with high value health and safety issues, yep, or long life with future updates. Yes, I would agree to that. I would agree to that. Like, if you've got, if you're sending something to Mars and you only have one shot to do it, that's a lot different than if you're developing an app that you can release today and then tomorrow and then the next day with no loss of health or anything like that. But clean software and clean design and knowing your goals is always going to be helpful no matter what. I have a few more questions, Joan. Actually, there's a bunch more here, and I can email you answers to them of my thoughts.
That actually would be great. I know that people have constraints around lunchtime, and so I don't want to have people stick around too long because you've got certain constraints within your office. But Chris, if you don't mind, and if you've got further questions from the audience, we can send this back out as a follow-up when we send out the links for the webinar. We can send out some responses to these questions if you're amenable to that.
I'll cut and paste this right now, and I will I will email it out to you so that you have it.
Great. Well, I'd like to thank you very much for taking the time today. It's wonderful to have our alumni come back that have really been able to implement systems thinking into the environment that they're in their workplace. And it's been a wonderful lesson. I really appreciated the idea of contemporary furniture and the concept of design that relates back to software there. So thank you very much. To our listeners, we do the webinar on a regular basis, although during the summertime our schedules change a little bit. So please keep an eye on the SDM website for upcoming webinars, and if you're on our mailing list, we'll also keep you updated as new webinars are posted. So thank you very much, and enjoy your summer, everybody.